Hi guys, today I want to simulate a multiplexer, but the first thing that I will do before using the VHDL is using LTspice, so that we can have a very fast understanding of what a multiplexer is. So basically we will select first the inputs A and B and the selector S. A multiplexer is basically a device which allows you to select between two inputs, A and B, through a selector S. You plug the A inside an AND with the S, and you plug the B inside the AND with the S, but negated. And finally, you joined everything together into a OR. So when the selector is equal to 1, then you have A as an output, and when it is 0, you have B. The symbol of the multiplexer, it is called 2 to 1 multiplexer, is 0, 1, selector, and Y. So we will first realize in this on VHDL+, and then we will switch to more complex topologies like the 5 to 1 multiplexer. So let's use the AND, to AND, and let's use the OR. So connect A inside the AND, connect B inside the AND, and the selector inside here, but with the inverter, of course. And the output will be called output out. No, there is no need for that. And now basically we have to select, for instance, an input as 1. So let's call it 1. And now we will run the simulation with the .p statement. So let's put A to 1. And let's put the selector also to 1. So we expect the result to be A. Let's run the simulation, and we have 1 volt here. So it is correct. Now let's put this guy to 0, and we have B, which is 0. So it is correct. Now let's make this as a component in VHDL+, just by doing the hierarchy, open this sheet symbol. He will create automatically this symbol here, but let's choose this input as 1 and this input B as 0. Remember that you have to write O, because 0 does not exist in VHDL+, and so this will be the output Y. Okay, so now you close it, you call this file save as with Mux2to1, and you open his sheet symbol, Mux2to1 01S, just move the S here, just move the S here. Let's draw a better symbol for this guy. Let's draw something like this, which is the most common symbol used for the multiplexer. And let's save it. Now let's open again another the multiplexer 0 to 1 like this. We don't need the they don't need the instance name, so let's save it without the instance name. Okay, now to do this multiplexer 5 to 1, we have to generate as much as we have to generate many multiplexer 2 to 1. Okay, to know how many multiplexer, it is quite simple. If you have to generate 5 input, this is the number of the input, and this is the number of the output. The multiplexer is a device which converts 2n to 1 with an n selector, meaning that if you have 5 inputs, the selector must be 3 bits. And so if instead you have, because 3 bits allow you to select up to 8, so 3-bit selector, 2 to 3, maximum 8 input. 2-bit instead, 2 to 2 is equal to 4 input. So Let's use, for instance, this as an input. Let's call it x. This will be y. Sorry, x, z. Other two input, w, k, and the other one, p. So we need another multiplexer here. Another multiplexer here. And the last one, and the last one here. Naturally, we will need a 3-bit selector, which we will call as an input S0, S1, and S3. S1 and S3. Let's connect the first row to S0, the second row to S1, and third row to S2. No, not 3, sorry. And so this is the multiplexer 5-to-1. I don't know, if you wanted to do a 8-to-1 multiplexer, for instance, the result is the same, okay? You have always to take as much as multiplexer as you can at the input. So you have 8 input in this case. So again, like this. Then for each true output, you put a multiplexer, like this. And since you have other two outputs here, you use another multiplexer, like this. So the construction of the multiplexer for many inputs is quite easy once you got the picture. Now what we want to do is to try this guy on VHDL. So let's open VHDL, new project wizard, and let's select the name of the project. First, the working folder. We will select a folder here, VHDL projects, as Mux5to1. And we'll select this folder here. The name of the project will be Mux5to1. Next, finish. So open new file, VHDL file. We will use the library IEEE, and let me remember just the intestation. Okay, library IEEE I use, sorry, it is the opposite. So start by the multiplexer 2-to-1. So first this guy here. Okay, so the entity is done by this 2 signal here. So entity Mux2to1 is and entity. Now port in 1, in 2, and S as input standard logic, and now Y as the output standard logic. So that's the entity. Now for what regards the architecture RTL of Mux2to1 is and architecture. Now, as you know, here we need a signal because there are two wires here which are inside the entity. So we need to define two signals here. What did it open? Okay. So let's call this signal W0 and W1. namely y will be equal to w0 or w1. Okay. And architecture, yes. So signal v0 and v1 as a standard logic. Now begin, and inside begin we will put w0, which is equal assigned to in1 and selector and s, w1 assigned to in2 and not s, okay, and naturally the output y, which will be equal to w0 or w1. I hope that everything is correct in the syntax. So file, save as, let's select the correct folder, which is Mux5to1. Let's call this file Mux2to1, save it. And now remember to put this guy as the top level entity, otherwise you will have some problems connected with the hierarchical, okay, with the hierarchy. Let's run the simulation and then let's hope that there are no mistakes and there are always v0 is used but not declared. Ah, sorry, I called this v0. v0 is enough. So let's run the simulation again and it should be fine, and it is fine. Okay. So let's perform a very quick simulation, but I think that there is no need because I already used LTspice to do this simulation here. So if the circuit is the same, I think that we don't need to test it. So now that it has ended the compiling, let's go on Tools, Netlist Viewer, and Directive Viewer. If it is the same as this, we are won. Yes, so in2 goes inside s with inside the end with the s negated, and in1 and s inside the end, and of course the or inside the y. Okay, so we can proceed to the multiplexer 5to1. We can close the viewer, and we can open a new VHDL file. So let's copy and paste this guy, entity 5to1 this time, and this time we need to define the entity of this. This is our 5to1. So as you can see, the selector now is a vector of 3 bits, and we have 5 inputs to. We have 5 inputs. So we have to define x0, x1, x2, x3, x4, or you can select directly. You can say directly x and to use a standard logic vector 4 down to 0 is the same. I wanted to show you this. I wanted to show you both of things. And the selector S is an input, but this time is a standard logic vector 2 down to 0. Okay. And this is with the point, and y is instead the output, so let's call it out standard logic, and that's it. Now architecture ATL of Mux5to1, this is important, is okay. Now we need to define the component. So component, and the component has the same entity as the multiplexer 2to1, so we need to copy this guy here. Component Mux2to1 is port this guy. Now, of course, we need the signals. We need the signals here because, as you can see, we need many signals this time. So let me highlight with yellow what signal we will need. This, which is the output of the multiplexer 1, this, and this one. We will call the multiplexer, this multiplexer here, as 1. This is as 2, M1, M2, and this is M3, and this is M4. Keep in mind that when you have to generate so much hardware like this, you can use the command generate, but I will show you in another video. So let's give a name to these guys, and let's call this guy P0, P1, and P2. So the signal P0, P1, and P2. Standard logic. Now, begin, we need just to say, to do the port map. I showed the syntax of the port map in another video, but this time I will do it more complete. So, M1 as Mux2to1 port map. Okay. Now we have to map this port here to the signal and components the signal and the entity that we have. So, input 1 in the first half adder, who is it? Let's check. To X. Did I choose the same? No, I choose other output. So, X0. Into to X1. And the selector S to S0. And the output Y will be assigned to P0. P0. We can just copy and paste everything here, but I repeat, you can use the command generate to do this. M2, M3, M4. So now, M2 receives this is X0, X1, X2, X3, X4. Okay, not this. M2 receives X2 and X3. So these are X2 and X3. And the selector here is S0. And the output is P1. Now, the Mux M3 receives P0 and P1 as an input. So this will be P1 and this will be P2. Okay. No, sorry. P0 and P1. My bad. P0 and P1. And the selector this time will be S1. Now, the last multiplexer receives as an input P2 and X4. So this will be P2. The output here is P2. P2 and into to X4. And the selector is S2. The output Y is assigned to Y. And that's it. Now we have to save this guy. Save as Mux5to1. And in the design, we'll assign this guy to top level entity and run the simulation. Mux2to1. I forgot the X. Mux. Okay, now let's run the simulation and let's go. Okay. I love to use also LTspice for this kind of simulation because you can also simulate the digital circuits as well. Naturally, it's not the same, but let's view the RTL viewer as always. Okay, so we have the first multiplexer, which receives the true input and the selector is 0. X3 in the second multiplexer is correct. Then the selector S1 goes in the second multiplexer, M3, and N1 and 2 as this output and as those two outputs. And yes, it is correct. This is correct. You can zoom in to verify that this is a multiplexer which is done correctly. And well, I can be that we can be very satisfied. To run the simulation, as always, you go on File, New, then go to University Program View WF, OK. You go to Insert Node Bus, Node Finder, List, and you pick up everything to the right and click OK. Y is your output and S is your selector. You can play as much as you want. You can put 1, 1, 1. And if we do put 1, 1, 1, it means that we are selecting the first input. Let's see that if it is true. Now let's run the simulation on both Spice and both on Quartus. So let's put 1 here. Let's put 1 here. Let's put 1 here, 1 here, 1 here, and 1 here. Let's run the simulation in the .op statement. 0, 0, 0, 0. This is 1, 0, 1, 0, and 1. So in VHDL+, it is correct. Now let's check on Quartus. Let's run the simulation. Run function simulation. Yes. Save. Okay, I open a bracket here. Yes, it is correct. As you can see, I put 1, 1, 1, 1 here, and I have the first input as 1. You can also do the ungroup, and you can select the bit manually. So you can put, for instance, I don't know, sorry, ungroup. You can put the bit manually. So let's put this guy to 0, and let's put this guy to 0. 1, 0, 0, we should select, let me check. 1, 0, 0 in which order? Ah, so the last. Okay, so we select this. We can select one of these, basically. Let's select 1, 0, 0, means that we are selecting, okay, 1, 0, 0, the x0, 1, 2, 3, x3. We are selecting x3. So let's put x3 equal to 1, just because I want to see it. x3 equal to 1. And now let's run the simulation. Run function simulation. Now I open a bracket. Here you can have some errors. If you do have some errors, you just need to go on Quartus, Tools, Options, and Ada Tool Options, and select the model sim correctly. Okay. You can do it simply by choosing your correct folder. And yes, with 1, 0, 0, we have you have x3 as the output, so it is correct. I think that we can end the video now, guys. Thank you for following me. I will upload everything, and thank you, guys. See you in the next video.